In today's lesson, we're going to look at another circle theorem, and that is the angle at the center is twice the angle at the circumference. Let me show you. So here we have the center of the circle, and if we draw an angle from the center, which then makes this chord here, it also makes this segment. But if we consider this chord here, then from somewhere on the edge of the circle, let's create the same chord. So this angle here has still created that chord there. So we've created the chord from the edge and from the center. And the basic relationship is that if this is angle x, then this will be double that. So for example, if this is 60 degrees, then this would be 120 degrees. Okay, let's do some questions and it will become very clear. Okay, so we've got exactly that same situation. We've got an angle from the center and it's created this chord. Okay, so the angle at the center is 100 degrees, so y is half of that, so y is 50 degrees. Now to work out x, we use the idea that the angle at a point adds up to 360. So x must be 260 degrees. Okay, in this situation here, the most important thing is that we have two radii. Therefore, those two lengths are the same. So this is actually an isosceles triangle, and we've shown that with those two lines there, and they point at the angles that are the same. So in fact x is also 48 degrees. So then looking at the triangle, the angles in a triangle add up to 180 degrees. So if x is 48, then the angle 48 plus 48 plus y must be 180. So y is actually 84 degrees. Now, having realized that y is 84 degrees, we use the idea that the angles on a straight line add up to 180. So z is going to be 96 degrees. Now, the reason this question is in this section is because actually we've actually got an angle from the circumference of the circle. So if you see that there, and we've created that chord, but we've also created the chord from the center as well. So the relationship between 48, which is on the circumference, and z, which is at the center, is that z is double x. Okay, at first glance it looks as if we haven't been given any angles, but if we notice that at the center the angles must add up to 360. So we've got x plus 3x, and that must be 360 degrees. So 4x is equal to 360, so in fact x is 90 degrees. So if x is 90 degrees, then y, which is on the circumference, is going to be half that, so y is actually 45 degrees. And if we wanted to find this angle, that's just 3 times 90, which is 270 degrees. Okay, let's find x first. It's normally the case that when it's labelled x and y, x is the first angle to find, and sure enough here, angles on a straight line, so x plus 120 degrees must add up to 180 degrees. So x is 60 degrees. Then we have x is the angle made on the circumference, making this chord here, or this segment. And we have an angle at the center, angle y, so angle y is double x, and x is 60 degrees, so y must be 120 degrees. Okay, the final question. As I said, let's work in x first, actually. Angles on a straight line add up to 180, so x must be 60 degrees. Okay, we can say that from the start. Now the thing to notice here is we have an isosceles triangle. In fact, we have two of them. We'll come to that in a second. But this here is an isosceles triangle because this is a radius. y must also be 60 degrees, so y is equal to 60 degrees as well. In a similar vein, we can work out w, because w angles on a straight line add up to 180, so w is going to be 40 degrees. Now noticing again that we have an isosceles triangle, a different one this time, so I'm going to put two lines to mark that they are the two sides that have the same length. So w, which is 40, also has the same size as z, so z is also 40 degrees. So z is 40 degrees. Now to find p, p is the angle at the center, so the angle at the circumference is y plus z, which is 100, so p is going to be 200 degrees.